Hi, my name is Amaya Echeverry, and my project is entitled Biopurification, utilizing classic water treatment strategies to improve air quality and produce a reliable food supplement using coconut husk and charcoal with Chlorella vulgaris and Spirulina major. So the three main problems that I came up with when trying to figure out an idea for an invention was the extraction of mangroves, air quality in homes in developing countries, and lack of clean water in developing countries. However, I decided to go with the second question. And this is because the EPA states that indoor air quality tends to be 2 to 5 times worse than outdoor air quality, and this is more prevalent in developing countries because since they don't have access to energy sources such as electricity most of the time, they've had to resort to other energy source methods such as biomass and biomass burning. And this releases a lot of dangerous pollutants such as particulate matter, which can be dangerous for the inhabitants. So all around the world, obviously pollution is a problem, and the way that certain countries have been looking to handle it is by using algae. And last year I did a project on seeing whether spirulina or chlorella would work better working together or separately to improve air quality, and I found that working together they work the best. And I also wanted to use these two algae this year because I've also found that they're both consumable algae that are very nutrient rich. And also, since they're natural phytoplankton, they can be found in almost all freshwater ecosystems, which makes them very accessible, and they're also very easy to culture. And as you can see, especially in the middle picture, air purification units tend to have a lot of parts, so not only can they be expensive, but they're very hard to maintain. And when I was doing research to see if any other company had done my project, I found that there was a company called Algenair, which produced a spirulina-based algae purification unit that focused on decreasing the amount of CO2 in an industrial home environment. However, what sets my project apart is one that I'm focusing on particulate matter, and the EPA states that particulate matter has been linked to cardiovascular and respiratory problems and premature death, and this is especially harmful in developing countries where they don't have access to proper health care. And also, I'm looking to make my product consumable so that can also provide a food source. So my questions were, would adding these other purifiers to an algae biofilter system increase efficiency? Would adding other purifiers to an algae biofilter system decrease bacterial contamination in the culture? And are certain easily obtainable natural filtrates better than others working together in the algae consortium? So my variables that I was checking were coconut husk and charcoal because they're both very easily accessible. And my hypothesis was that the coconut husk would not perform as well as the charcoal in being more efficient in increasing the overall air quality more quickly and decreasing bacterial contamination. And the charcoal would perform better than the coconut husk and the control, but that the coconut husk would perform better than control overall. And my null hypothesis was that the coconut husk and charcoal would have no effect on the outcome. So for my procedure, I took a tote and used it to simulate a 20 by 20 room, and then I set tubing from an aerator to go through either the extra filtrate, such as the coconut husk or the charcoal, and then go into the algae, which I filled with 15 milliliters of the algae consortium that I used, and then I used a match to simulate the biomass burning, and I used an air quality meter to track the particulate matter concentration using a phone that took a picture every 1 minute for 50 minutes to collect my data. And then for my bacterial concentration data, I took a milliliter of the algae consortium before and after every single experiment, and then I put that onto an agar plate using a cell spreader to spread it evenly, and then I taped it shut and put it into an incubator for about 1 to 2 days, and then I checked the bacterial concentration on the surface. So for the air quality, and the average percent change in the particulate matter 1.0, 2.5 in overall air quality, the coconut husk outperformed the other two. So it performed better than charcoal and the control. However, the 1.0 concentration was the only one that it was statistically significant for, with a p-value of 0.05 exactly at the alpha value of 0.05, which simply states that I can say confidently that it did have an effect on decreasing the particulate matter concentration. And in this graph, you can see that the charcoal decreased the bacterial concentration because it's going the lowest, which is what we wanted. And this was statistically significant also with the p-value of 0.05. So here's what went right and here's what went wrong. And overall, to construct this prototype, the aerator would be $12. The plastic cylindrical container would be $2. The LED grow lights would be $10. And for a 24-ounce bag of charcoal, which we'd probably only use an ounce of, it would be $15. So that would be 50 cents for an ounce. And then for the coconut husk, for 3 4-pound bricks, it would be $20. So if you were only to use an ounce of this as well, it would be about 20 cents per ounce. So overall, my project would be sold at $50 because that would include shipping, the production of other air filtration units, as well as paying for employees and other things. And here's my bibliography. Thank you.